Today I'm going to talk to you about periodic graphs. There are three main periodic graphs that we study in maths methods. The first one is the sine graph. So if I draw the sine graph, let's use the domain from 0 to 2 pi if we're in radians. So of course we've got the y-axis here and the x-axis here. The sine graph starts with 0 degrees, and if we're only going positive, remember it can go back to negative and it can continue to infinity and negative infinity that way. So we're purely just looking at that domain. Now it's a periodic function. That means it repeats itself. So this is just one period. One period is the cycle before the graph then repeats itself. So at this point we have 2 pi. Now if you've studied the unit circle, you'll know that the unit circle gives one full period of the sine graph, cosine graph and tan graph. If we look at the key features of this graph, we know the period of the graph is 2 pi, one cycle. We also can see that the maximum point on the sine graph, looking on the y-axis, goes to 1, and the most minimum point goes to -1. This is called the amplitude. The equilibrium position is the mean, the central position between the maximum and the minimum. And of course the difference from the equilibrium to the maximum gives us the amplitude. If we look at halfway around the unit circle, we know that sine begins positive, 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 and then when it reaches pi degree radians, it then begins to go to 0 and then negative, 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 negative. And in fact, if we look at 90 degrees or pi upon 2 radians, we know that that's when the y value for sine reaches 1. So we know that that's the maximum, and the same for -1 with 3 pi upon 2 radians. Now that's the main feature of the sine graph. If we look at a reflected sine graph, we know that it's been reflected on the x-axis. If I draw that in a dotted line, it too has a period of 2 pi. It's just going anti-clockwise around the unit circle. Now let's look at another periodic function. Let's look at the graph of y equals cos x or cos theta. If we have theta along here and y-axis along here, remember we'll just stick with the domain from 0 all the way to 2 pi. And let's look at what happens with cos. Well, the cosine graph begins at 1 and it comes down to a negative and then back up to positive. This is one cycle or one period of the cosine graph. It cuts through from the unit circle as we go round the unit circle. When it gets to 90 degrees, the x-coordinate is 0, which means at 90 degrees or pi upon 2, that's when the graph goes from positive down to negative. At pi degrees, we're sitting at -1. And at 3 pi upon 2, we're going back up to 0 and then back to positive to the fourth quadrant, which is where cos is positive. And of course, one cycle of the cosine graph, or its period, is 2 pi. So 2 pi degrees is its period. And that's pretty much the most common periodic graph. There is the graph of tan theta, which I'll look at in a different video.